So hello everyone. So today we are going to see the certain problem based on the E0 cell. I think my video is not visible or maybe not clear, so I am taking back these lectures. That is a problem. You can make a heading, problem based on E0 cell. Make a heading here, problems, or I can write down, we can say numericals based on E0 cell. Okay, so first is write down the question along with me, or you can see better write the question along with me. Write symbolic representation of cell formed by using following standard cell at 298 Kelvin. Write the cell representation net reaction and calculate E0 cell. Calculate E0 cell of the following. It's very simple question. Okay, so E0 Zn plus 2, Zn is equal to minus 0.76 volt, and E0 Ag plus slash Ag is equal to 0.8 volt. Clear? So this is a one question, simple question. Point number one, these are known as reduction potential values, which is given in your textbook. Please check it out. I don't know, some page number will be there. Okay, so you can check it out, certain values that is of an E0 cell values. These are known as an reduction potential values. Okay, remember one key point, very important point in your mind: always solve the problem of E0 cell. Always solve the problem of E0 cell, or in short, one thing you remember in whole electrochemistry chapter, the value of this potential should be always reduction potential only. The value should be always reduction potential only. If they have not given reduction potential value, you have to convert the reduction potential value and you have to solve. And I hope you know the relation, that is E0 reduction is equal to negative of E0 oxidation. Clear? Suppose someone has told, suppose E0 Zn slash Zn plus 2, okay, equal to 0.76 volt. Now this is the oxidation potential value of zinc. This is the oxidation potential value of zinc. This is not the reduction potential. If this type of values has given in your question, then you have to convert first into the reduction potential value and then you have to solve. So now by using this value I cannot solve the problem, so I have to convert this value into reduction potential. What you have to do? Just opposite the number. So E0 Zn plus 2 slash Zn is equal to minus 0.76 volt. Clear? So always remember that reduction potential value is always the opposite of oxidation potential value, and similarly oxidation potential value is always the reverse of reduction potential value. But the problem and numerical should be always solved by taking the reduction potential value. Why, sir? Because to maintain the standardity, that's it, standard condition, nothing else. Clear? Because all the answers of electrochemistry, especially the cell potential value, they have derived based on the reduction potential value. And the table which is given in your textbook, you can see some page number is there, you can see the textbook, they have started from minus then it will increase, then it will go to the 0, then again it will increase. So that the value starting from the lowest to the highest, that all the values are nothing but the reduction potential values. They have taken the values based on the reduction potential value. So all the problems, whether the problem of electrochemistry, E0 cell, further classes we are going to solve the Nernst equation problem, pH problem, KW problem, pKW problem, all the problems should be solved by only reduction potential value. Clear this part? Chalo, point number 1 this. Point number 2, make a note, that is, now they have two values they have given. Okay, now how to decide which will be the anode, which will be the cathode? So there is a very simple trick. You remember, lesser value will always act as anode, and but at anode oxidation occurs. This is shortcut you to remember. Lesser value, there are two values they will be given. This two half cell value will be given. The half cell which is having the lesser potential value, that half cell lesser potential value is known as an anode. At anode oxidation occurs, and oxidation means loss of electron, this you know. So lesser value will always act as anode. At anode oxidation occurs, and oxidation means loss of electron. Is it visible to you, beta? Is it visible, no? So lesser value will always act as anode. Okay, correct, it's visible. Lesser value will always act as anode, and at anode oxidation occurs, and you know oxidation means loss of electron, or electron will be lost. Another more value, but opposite, cathode, and at cathode what will occur? At cathode reduction will occur. Please you repeat number of times during this chapter. We will repeat this number of times during this chapter. At the end of this chapter I will solve number of questions. I know that. This video I am recording because of some issues in my previous video. That's why I am solving this. Don't worry. After the completion of this electrochemistry chapter, we will solve number of questions. Okay. So lesser value will act as anode, and at anode oxidation occur, and oxidation means loss of electron. Electron will be lost. Similarly, more value means cathode means reduction. This point number 2. Is it clear to you? Clear. Chalo. Third point I would like to discuss, that is the cell representation. That is also very simple. Cell representation. Now how to represent the cell? Everything should be represented, yes or no? You are representing, no? In paper also you are representing. First you will write down MCQ, then question answers. You are writing point wise, and you are doing certain underline on certain things. You are doing the diagram, and diagram also you are doing the labeling. Yes or no? In my exams, and when I write down theory exam, you are writing the diagrams. So you are representing. So similarly you have to represent a cell also. So how to represent the cell? So there is a one trick. Trick what means? Always write down first anode. First write down the anode, then write down the cathode, and this anode and cathode are separated by two parallel lines. This represents the salt bridge, and you know what do you mean by salt bridge. First write down the anode, then write down the cathodic portion, and this anode and cathode are separated by salt bridge. How to write down the anode? We will see here. See now this question. Write the symbolic representation of a cell. That's it. And cell they have given this E0 Zn plus to Zn, E0 Ag plus Ag. This cell they have given. Now I will show how to write down the cell representation. I hope I have done in some video, but once more we will revise it. First thing you should see whether they have given the reduction potential or oxidation. If they have given reduction potential value, proceed the problem. But if they have given the oxidation potential value, first try to convert into the reduction potential value and then proceed the problem. Now here with the God grace they have given the reduction potential value only. They have given the reduction potential value, means proceed the problem now. See now who is less here? As we have discussed here, this is the reduction potential value of zinc and this is the reduction potential value of silver. So this is a zinc minus 0.76 volt and this is the silver, so this is 0.8 volt. So this is less. This less means this will act as anode, and this is more means this will act as cathode. So as it is very simple, clear cut that one who is less anode, one who is more cathode. The reduction potential value having the lesser oxidation, the lesser reduction potential value will act as anode, and more reduction potential value will act as a cathode. First point this. Second point, now at anode what will occur? Oxidation. Means this will undergo oxidation. Zinc will undergo oxidation, and at oxidation there will be loss of electrons. So write down the reaction of at anode. So write down the at anode Zn plus 2 electron. So this is the anodic reaction. Write down the cathode. So at cathode what will occur, beta? Reduction. Reduction means what? Gain of electron. And who can gain the electron? Iron. So a metal can lose the electron and iron can gain the electron. So that's why anodic reaction I am starting from metal because they will lose the electron, and cathodic reaction I will start from iron because they will gain the electron. Who is at a cathode portion? Silver. So silver ion will act as cathode and it will gain the electron. So Ag plus electron will form a what, beta? Ag. Clear? This is the anodic reaction, this is the cathodic reaction. Okay. Now this is 2 electrons, here also there will be 2 electrons. So you have to multiply by equation 2 by 2, multiply by 2. That's it. So here 2 will come, here 2 will come, here 2 will come. Why I am multiplying by 2? The reason is to maintain or to make the same electron which you are doing in standard 10. Equation 1 multiply by 3 and equation 2 multiply by 2. Then we are cutting x value, we are obtaining y in similar way. So here 2 electron will get cut, 2 electron will get cut. Write down as it is, Zn plus 2 Ag plus, okay, it's like a redox reaction as you know, Zn plus 2 Ag. So this is your net reaction. This is known as a net reaction. Yes sir, they have told on here net reaction. Clear? Now symbolic representation also I will show you, don't worry. Here how many number of electron transfer? Beta 2. So here number of electron transfer is 2. So n represent number of electron transfer. So why you are writing now? I am writing because in the further classes we are going to see in the Nernst equation. So here n is equal to 2. Now we will write down the cell representation. In cell representation I told you first to write down the anode. Beta who is at anode? At anode zinc is there. So see, zinc is converting into Zn plus 2. So write down in this way, Zn is converting into Zn plus 2. Zn is converting into Zn plus 2. So you have to make a line between the atom and its active ion at anode. Okay, then salt bridge. Now who is at a cathode? Now at a cathode we have silver. So at silver what it is there? Ag plus is converting into Ag. So Ag plus is converting into Ag. So at anode you should write down first atom and then its active ion separated by a line. At cathode you have to write down first the ion and then the atom separated by a line. Need not to write down these numbers, it's okay. If you write down, don't write down, it's okay. Okay. Now this Zn, it's a solid portion. So write down here S. This is also a solid portion. Write down here S. Now Zn plus 2, these are the ions, and ions will be in the solution. So they will be having certain molarity. So you can maintain any molarity, 1 molarity, 2. It is a standard cell 1 molarity. But if it is not a standard cell, it can be any molarity. So write down here. I can write down is just now I am writing 1 molarity, but you can write down also. So when the 1 molarity will come, 1 molarity is only for the standard cell. The cell which is working at 298 Kelvin, 1 bar pressure, and the concentration of the cell is maintained to be 1 molarity. But it is very difficult to maintain 1 molarity. Okay. So this is your cell representation. Are you understanding or not? Clear this part? Chalo. So write the symbolic representation. So written symbolic representation using the following standard cell at 298 Kelvin. Write cell representation. Cell representation also written. Net reaction also have written, and calculate E naught cell. Now the question come at E naught cell. So what is the formula for E naught cell? E naught cell is equal to E RHS minus E LHS. E naught RHS minus E naught LHS. This 0 represents standardity. But who is at the RHS portion? So if I stand on this, the RHS portion is a silver. So at RHS cathode will come. So I can write like this also, E naught cathode minus E naught anode. Here who is at a cathode? Silver. So write down E0 Ag plus slash Ag minus E anode. Who is at a anode? Zinc. Zn plus 2 slash Zn. Yes or no? Silver value they have given. Yes, they are given in the question. And this value will be given in the question. Need not to remember. So E0 Zn Ag plus Ag is 0.8 volt sorry 0.8 minus, this is the system minus, okay, and Zn value is also given the minus, so do a bracket minus 0.76 volt, so answer will be 0.8 plus 0.76. So if you add it, you get the answer as 0.76, 0.80, so 6, 15, 1. So answer will be 1.56 volt. This is your net answer. Take it out. Clear? So most of the things I have discussed in this first question. Right on this. So your answer is 1.56 volts. 1.56 volts. Are you understanding or not? Clear? This is 1.56 volt. Clear? Chalo, we'll see the next question. So we'll see the next question. Write down. Chalo. Next question also same. Write symbolic representation formed by two half cell at 298 Kelvin, right? Cell reaction, okay, cell representation, and calculate E naught cell for E0 Mg plus 2 slash Mg equal to minus 2.37 volt and cobalt E0 CO plus 2, but it is cobalt. This is not carbon monoxide, it's a cobalt. This is carbon monoxide, this is cobalt. Okay, some of the students say this is carbon monoxide. No, this is cobalt. Okay, now in a 12th standard you should know this. Okay, you do hard work and concentrate. One day school will get open only. Clear? And you have to give class 12 exam also, so don't be in that dreams that class 12 exam will not be taken. Class 12 exam will be taken, NEET also will be taken, so start to read now. Okay, chalo, we will see this question. Ready? Please you take out your book and pen, don't sit simply. Okay, so again we will listen this question. Write the symbolic representation formed by two half cells. So that two half cells they have given. First check the half cell whether its value is given of a reduction or oxidation. So see, they have given the reduction potential value, so need not to issue. Most of the time they will give the reduction potential value only, just to sometime to get or to make you confusion, they will give you the oxidation potential value. Most of them they will give you the reduction potential value only. So write the symbolic representation formed by two half cell at 298 Kelvin. Write the cell reaction, cell representation, and calculate the E naught cell, so and so. First we will see from this who will be acting as an anode, who will be acting as a cathode. So that shortcut trick I told you, lesser value anode, oxidation, loss of electron, more value cathode, reduction, gain of electron. Again and again you repeat, one day you will be in your mouth. Okay, so lesser value anode, at anode oxidation, loss of electron, more value cathode, at cathode reduction, gain of electron. Now who is lesser value? So this is minus 2.37 and this is 0.28, so this is the lesser value. So this will act as anode and this will act as cathode. A simple and shortcut trick. One who is yes or no, minus 2.37 will be less or more? Minus 2.37 only will be less. So this is anode, this is cathode. Now we write down the reaction. At anode what will occur? At anode loss of electron will occur. So this is magnesium. It will lose the electron. How many? 2. They have shown here. So 2. Mg plus 2 electron at anode. or I'll write down at anode, it will be looking good. If you don't write down, it's okay, but in theory exam write down at anode. Mg will give Mg plus 2 electron. At cathode, CO plus 2 will give, CO plus 2 will gain 2 electron, because it is plus 2 only, no? So 2 electron will be gained. If it was plus 1, then 1 electron it will gain. Then you have to maintain the balance, multiply. But here CO plus 2 means it will gain 2 electron. So here 2 electron will form CO. Clear? CO. So need not to multiply, because here, as you can see here also 2 electron, here also 2 electrons. So net transfer of electron is 2. Net transfer of electron is 2. So here 2 electron will get cancelled. And what is remaining? That is your cell reaction. Beta, this is your cell representation. Okay, this is your cell representation. So what is symbolic representation? That anode and cathode are separated by 2 lines, which is a salt bridge. At anode, first write down atom and then its respective ion separated by a single line. At cathode, first write down the ion and then atom separated by a single line. So this is your cell representation. Now I am writing the symbolic representation. See, first write down the anode. Who is the anode? Magnesium. Then it is converted into its active ion, so separated by a line, Mg plus 2. Clear? 2 lines. These 2 lines represent what? Salt bridge. Then CO plus 2, and single line CO. Okay, this is solid, and this is aqueous, It can be any molarity. If it is 1 molarity at 298 Kelvin, 1 bar pressure, standard cell, condition, standard cell. 1 molarity 298 Kelvin and 1 molarity 298 Kelvin, 1 bar pressure, standard cell. This you can read in your textbook. Clear? So this is your beta what? This is your symbolic representation. Clear? This is your symbolic representation. Now we'll come on the E naught cell. So E naught cell, I told you ERHS minus ELHS. Okay, at RHS, right hand side we have cathode, so E naught cathode minus E naught anode. At cathode what we have? At cathode we have cobalt, so E0 CO plus 2 slash CO minus E0 Mg plus 2 slash Mg. And always solve the problem by using reduction potential value only. See, here they have given the reduction potential value, just keep it the values here. First E0 CO plus 2 CO is minus 0.28, this is the system minus, and E0 Mg plus 2 Mg is minus 2.37. So here minus 0.28 plus 2.37. Okay, minus plus subtraction, bigger numbers and bigger number is this, so sign is plus. We'll see this 2.37 and minus 0.28, subtract. So here I'll get 2, 70 minus 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 9, 0.2. So around 2.09 volt. Right on this. Around nearly 2.09 volt. If it is a minor mistake, let me know, because I don't have calculator, I am solving in this way. So if it is having any certain minor mistake, please let me know. Clear? Sure. Return beta. Go to the third question. Understanding or not? Can I go for third question? Chal. We will see third question. Third. The potential of cell. The potential of a cell is 3.17 volt at 25 degrees Celsius. See, 25 degrees Celsius means standard cell. Convert this 25 into Kelvin, 273 and 298 Kelvin, yes or no? So this shows standard cell. Understanding? Okay. Chalo. So E0 Ag plus slash Ag is equal to 0.8 volt. What will be the oxidation potential? What will be the oxidation potential? What will be the oxidation potential for standard cell, for standard half cell Mg plus 2 slash Mg for the given reaction, and cell they have given Mg plus 2 slash Mg salt bridge Ag plus slash Ag. So from here you have to determine the value of Mg plus 2, yes or no? Chalo. So we will read the question first. The potential of a cell is 3.17 volt, means the potential of whole cell, the cell which comprises of magnesium and silver. So I can write like this, beta. E naught cell they have given, total E naught cell they have given is 3.17 volt. Clear? You know what do you mean by E naught cell? So E naught cell means E cathode minus E anode, yes or no? 3.17. Now just try to determine who is cathode and who is anode, that's it. So it is very clear, no? They have given the cell representation. So always the first portion will be anode and second portion will be cathode. Clear? Chalo. So cathode is silver, anode is magnesium, and for silver they have given the value, and we ask the value for magnesium. Simple question. But listen here one thing. I hope you understood this. Don't solve directly the value of magnesium by just saying this. You have to show the cell reaction. You have to show the cell reaction. That is a rule. If they have asked in 1 mark, directly you can solve. But if they ask you for 2 marks, then you have to show the cell representation. So first we have the cell representation. Who is here at anode? At anode we have magnesium, and you know magnesium will lose the electron. So at anode, magnesium will form Mg plus 2 electron. At cathode, Ag plus electron gives Ag. Okay, so here there is 2 electrons, so here 2 and here 2. N is equal to 2. So 2 electron get cancelled. Mg 2 Ag plus Mg plus 2 plus 2 Ag. If they have given this question for 2 marks, then this much you have to show. Okay. So now who will be acting as a cathode? Silver. So E0 Ag plus slash Ag. What will be the anode? E0 Mg plus 2 slash Mg equal to 3.17. What is the silver value? Silver is 0.8 beta. 0.8. What is magnesium value? You have to find out. E0 Mg plus 2 slash Mg equal to 3.17. So this will come here, this will go. So 0.8 minus 3.17 equal to E0 Mg plus 2 slash Mg. Clear? This will become plus minus minus and bigger number sign. So E0 Mg plus 2 slash Mg is equal to minus, we'll do here minus 3.17 minus 0.8. Okay, so here I can write down here 7, here 2, 11 minus 8 means 1, 2, 3, 4, 5, 6, 7, 8, 3. I am not so good at maths, that's why I am doing this calculation. you can do of yourself also calculation. So minus 2.37 volt. Write down this. Then we'll go to the next question. E naught cell. Write down next question. E naught cell. E naught cell of electrochemical cell are given below. First is Ag/Ag plus salt bridge Cu plus 2 slash Cu. E naught cell is equal to minus 0.46 volt. Zn slash Zn plus 2 Cu plus 2 slash Cu. E naught cell 1.1 volt. These two cell representation they have given, and now listen what they are telling. They are telling by using this two cell info, means this two cell information calculate E naught cell for Zn slash Zn plus 2 salt bridge Ag plus slash Ag. Clear? Sure. So by using this two cell info, this is a bit complicated question. Okay, so by using this two cell info, calculate E naught cell for Zn slash Zn plus 2 Ag plus slash Ag. Now how to solve this? So they ask you to sell E naught cell for this, no? So first write down the E naught cell for this cell. So E naught cell is equal to E naught cathode minus E naught anode. Okay, now here who is the cathode? So this portion will be anode and this portion will be cathode. So who is at anode? So anode is zinc. So sorry, cathode is silver. So E0 Ag plus slash Ag minus E0 Zn plus 2 slash Zn. So in this way you can calculate. If you have to calculate in short for this. So by using this two, somehow if you come by doing certain plus minus, if you come on to this value and you get the answer for this, means you got the E net solve for this. So how to solve this? See, first we'll start here. I have to anyhow come here in this format. By using these two equation, I have to derive the format of this E0 Ag plus Ag minus E0 Zn plus 2 Zn. If I derive the format of this, I can get the E naught cell value. Now see here, first E naught cell, for first we will do E naught cell equal to E cathode minus E anode. Who is at cathode? Cu plus 2 slash Cu. Who is at anode? E Ag plus slash Ag. 0 0. And for this how much E naught cell? Minus 0.46 volt. Yes or no? Yes. So equation number 1. Similarly, I can derive for this also. E naught cell equal to E cathode minus E anode. See the second cell. Who is at cathode? So copper is at a cathode. So E0 Cu plus 2 slash Cu minus E0 Zn plus 2 slash Zn. And for this E naught cell is 1.1 volt. Okay, this is 2. Now you can see here copper is common here. So if I subtract 1 and 2, so I can get copper cancel. I'll get the equation related to these two. Then I will derive in the format of this. Clear? So what I will do, subtract 1 and 2. Subtract 1 and 2. Clear? So 1 is E0 Cu plus 2 slash Cu minus E0 Ag plus slash Ag minus, open the bracket, E0 Cu plus 2 slash Cu minus E0 Zn plus 2 slash Zn equal to, which is the first value? First is minus 0.46 minus 1.1. Yeah. Now see here. Minus come means bracket comes, no? So E0 Cu plus 2 slash Cu minus E0 Ag plus slash Ag minus E0 Cu plus 2 slash Cu minus plus E0 Zn plus 2 slash Zn minus here plus minus addition and sign remains minus. So 1.1 plus 0.46. 1.1 plus 0.46, so answer is 65.1 minus 1.56 minus 1.56. So here this is minus, so answer remaining is minus E0 Ag plus slash Ag. This only we need, no up to, and plus E0 Zn plus 2 slash Zn minus 1.56. Clear? But beta we need Ag should be positive and zinc should be negative. Here Ag is negative and zinc is positive, so just reverse it or minus multiply both the sides. So if I multiply minus both the sides, what I'll get the answer? I get the answer minus plus. So E0 Ag plus slash Ag minus E0 Zn plus 2 slash Zn equal to minus plus 1.56. This is nothing but the required answer. Write down this. Written? Understood why I have multiplied the minus on both the sides? Because the question we need is E0 Ag plus slash Ag and minus E0 Zn plus 2 Zn. But in the final derivation we derived minus E0 Ag plus slash Ag and plus E0 Zn plus 2 Zn. So I have to multiply minus on both the sides. Clear? So today's last question we will solve, then we'll wind up the lecture. Okay? Sure. The standard cell potential of electrochemical cell constructed by using Cr and Na, and they have given certain value E0 Cr plus 3, Cr equal to minus 0.74 volt and E0 Na slash Na plus 2.7 volt. Okay, and question remains same. Write the cell representation, symbolic representation, and calculate E naught cell. First, what you do, beta? Pause the, written the question. Written? So write down the question, that is calculate E naught cell representation and symbolic representation. Now see, pause the video, try to solve the answer. Okay, then again play the video, I will show the solution. So chalo, pause the video. 1, 2, 3. Okay, so I hope you have solved the question and your answer should be minus 1.97 volt around. You should get this much answer. Clear? No means check it out. The question first comes, see this is oxidation potential, this is not a reduction potential. Always before starting the question you should see the potential value, whether they have given the reduction or oxidation. Question will be always solved by reduction potential value only. So this is the reduction potential value. So first convert into this is the oxidation potential value, first convert into the reduction potential value. So E0 Na plus slash Na equal to minus 2.71 volt. Clear beta? Chalo, now we write down the anodic and cathodic portion. So they have given here minus 7.4 volt and here they have given minus 2.71 volt. So who is the less? Less is the sodium. So this is anode and this will act as cathode. Clear? One who is less anode, one who is more cathode. At anode oxidation, oxidation, loss of electron. One who is less cathode, cathode reduction, reduction, gain of electron. Who is anode? Sodium. So at anode, at anode who will come? Sodium. So Na will come Na plus electron, and at cathode chromium Cr plus 3 electron gives Cr. So this will be multiplied by 3. So why? To make electron same. 3 electron, 3 Na plus Cr plus 3 Na plus Cr. Clear? Chalo, done. This is cell representation. Symbolic representation. Symbolic representation, I told you, first anode, cathode, separated by two lines, salt bridge. Anode means atom and its active ion separated by single line. Cathode means active ion and anode, active ion and atom separated by single line. So who is that anode? Sodium. So Na is converting into Na plus, salt bridge. Cathode means Cr plus 3 plus Cr. This is solid, and this will be aqueous. Chalo. Cell representation, symbolic representation. We'll calculate E naught cell. So E cathode minus E anode. Who is at a cathode? At cathode we have chromium. So E0 Cr plus 3 slash Cr. Who is at anode? At anode we have sodium. Na plus slash Na. E0 Cr plus 3 Cr minus 0.74 minus E0 Na plus Na. Now reduction potential value you should take out. So here minus bracket, you take minus 2.71 volt. So answer will be minus 0.74 plus 2.71. Minus plus minus, bigger numbers and plus. So 2.71 is 0.74. 1, 2, 3, 4, 6, 7. 10 minus 7, 3. 1.37 volt should be your answer. 1.37 should be your answer. 0.74, no? Yes. This should be your around answer. If any mistake is there, please let me know, because I may commit a mistake in this plus minus because of the calculator. Up to here, if it is correct, means correct, means then mathematical part you to see it. Clear? So take a note. That's it. In the next class, I will do the standard hydrogen electrode. Thank you.